Hey, welcome back. It's been a while here, but this is going to be our review for the upcoming test that we have, our big mini common assessment that we have up and coming. Let's take a look at an old test here and see what we can get done here with this. Okay, with this. First one here, this is an old test. It says direct current is a type of current that runs through electrical lines into your house. Well, direct current is DC current, and as we've learned here, direct current is what we used quite often with our batteries. To go along with that then, that we know DC is for batteries. So it's not what's coming into your house. To fix this, I'm going to say alternating current, and my reason why is because it's going to go, the current goes back and forth and doesn't have to travel long distance. Okay, my next one then, I'm going to make this thickness here a little bit thinner, see if that helps any. Metals allow current to flow because metals have very high resistance. Well, resistance is the opposition to the flow of electrons, so I would say that's false. First one was false as well. So my fix would be very low resistance, and again my reason why is resistance is the opposition to the flow of electrons. Okay, our next one here. Both of these circuits are series circuits. Well, as I look at this, first thing here it says both, and if you guys have paid much attention over the last couple of days, we've done a lot of work with parallel and series circuits, and you see that the first one has one path for the electrons to flow. They never have a choice to go any other direction. All right, it's going to go one way. Now, there's no way for it to split. Here, the electrons can keep going this way, or they can go that way. So, I would say this is false, and the reason why I would say is because I'm trying to find a good way to write on this. My reason why would be, my fix would be, I'm just going to say circuit A. And the reason why is there is only one path for the electrons. Again, my handwriting is going to be really bad because it's just not very easy to write on my computer. I'm not able to disconnect the tablet part. Okay. A current of 3.7 amps is running through a circuit like the one above with a resistance of 1.5 ohms. What is the voltage? So, I know that this is my current, this is my resistance, and they're asking for voltage. So I'm going to use an equation that uses V, I, and R. That's V equals I times R. The current in this case is 3.7. The resistance is 1.5 ohms. And if we go to find the voltage for that, pull my calculator out real quickly here. You get a voltage of 5.1 volts. Okay, so fill in the chart below. You heard it, we're going to be filling in charts. Well, for this, I'm going to follow my steps for a series circuit. The first step is to plug in the givens. This is 10 volts. Resistor 1 is 20 ohms. Resistor 2 is 19 ohms. Resistor 3, I guess that's 23, and this is actually resistor 4. is 20 ohms. Well, the second step then is to find RT, and that gives me a total resistance of 59 ohms. The third step is to find IT, and to do that we're going to use VT equals IT times RT, and we get 10 equals IT times 59. And IT turns out to be 0. I'm going to round it up to 17 amps. Now for series circuits, what do we know? Well, we know that all of the currents are the same. So my next step then was to use those concepts. And this is my concept here, is that all the currents are the same. Well, the last part then is to use V equals IR again to find our voltages. So I'm going to use V equals I times R, and I'm going to say that 0.17 times 20, 0.17 times 19, and then I'm going to do 0.17 times 20 again, but I'm not going to write it twice because it's going to be the same answer for both of those. 0.17 times 20 gives me 3.4. And then this one's going to be really close to that. It's going to be like probably 3.2, I'm guessing. 10 divided by 19. Shoot. 10. Sorry, I'll do this right here again. 0.17 times 19 gives me 3.2 when I round it. Okay, so that's our voltages. Alright, the last one I'm going to do here then is our, this one's a parallel circuit, because you can tell we have these paths, we have these choices, multiple paths for it to go here. Alright, the current has these multiple paths it can take. So the first step is again to plug in the given information. So that's 9 volts, this is 90 ohms, this is 45 ohms, and that there is 180 ohms. Our second step is to use concepts. Well, what do we know? Voltages are going to be the same. So all those are going to get 9 volts. Third step is use our equation. V equals I times R. Voltage is 9 I times 90. And it's going to be 9 equals I times 45. And then 9 equals I times 180. So when I go to do this, I'm going to take 9 divided by 90. 9 divided by 90 is going to give me 0.1. 9 divided by 45 is going to give me 0.2. And then 9 divided by 180 is going to give me 0.05. So now I can just plug these in over here. 0.1, 0.2, 0.05. The next step is to find IT. Well, we're just going to add these up, and that's going to give me 0.35 amps, amps, amps. The last step here then is to simply multiply across. Well, that's just 9 times 0.35. And we now have identified this total resistance to be 3.15 ohms. And again, I just simply took 9 equals I did that wrong. It's not 3.15. Got ahead of myself there. 9 equals 0.315 times RT. So I'm going to divide by 0.35. My apologies to all of you guys. 9 divided by 0.35. Something didn't seem right as I was doing it. And we get a total resistance then of 25.7 ohms. Sorry for that confusion. Well, hey, I hope that was beneficial and helped you guys prepare a little bit for your test. I'll catch you guys on the flip side.